Every single second you're using your computer, there's this incredible high-speed juggling act happening just behind the screen. It's the magic that lets you browse the web, listen to music, and type an email all at the same time. Today, we're going to pull back the curtain and look at the secret sauce that makes it all work: threads. Let's dive in.
I mean, really think about it. What's your computer doing right this second? You're watching this, of course, but I bet you have other tabs open, maybe some music streaming in the background, notifications could pop up at any moment. So how does it all happen at once without the entire system just crashing? Well, the answer is actually pretty brilliant.
So to really get a handle on this, we're going to build it from the ground up. First, we'll cover the basic layers of how a computer even works. Then we'll see how it juggles whole programs. After that, we zoom in on the main event, threads. We'll see them out in the wild. And finally, we'll understand why they are just so important for pretty much every piece of software you use today. Okay, before we can even begin to talk about threads, we've got to do a super quick refresher on the 3 fundamental layers that make your computer tick. Trust me, getting this foundation right is key. It all starts right here, with the application you're actually clicking on and interacting with, your web browser, that game you're playing, even a simple text editor. This is the software layer. But here's the thing, software doesn't just run in a void. It needs a manager, and that's the operating system, or OS. Think Windows, Mac OS, Linux. The OS is like the master conductor of an orchestra, managing all the computer's resources, making sure every program plays nice together. And finally, the OS is the one that actually talks to the physical machine, the hardware. We're talking about stuff like RAM, which is the computer's short-term memory, and most importantly, the CPU, the central processing unit. The CPU is the brain of the whole operation. It does all the real work, executing the instructions that make everything you see happen. All right, we've got our layers. Now let's kick it up a notch. What happens when we want to run more than one of those programs at the same time? Well, this brings us to the really powerful idea of multitasking. You've heard this word a million times, right? In the world of computers, multitasking is just the OS's incredible ability to juggle multiple programs at once, creating the seamless illusion that they're all running at the exact same time. Every time you flip between your browser and your music player, that's multitasking right there. But here's the secret trick. Your CPU isn't actually running all those things in the exact same millisecond. No, instead, it's doing something really clever called time sharing. It gives a tiny slice of its attention to one program, then instantly switches to the next, then the next. And it does this so unbelievably fast that to our human brains, it feels perfectly simultaneous. And this really shows you just how far we've come. I mean, back in the day, computers could only do one thing at a time. Seriously, you had to close one program completely just to open another one. Today, we don't even think twice about having a dozen apps running all at once. That is the power of modern multitasking. So, multitasking is all about juggling different programs. But what about all the work that's happening inside a single one of those programs? This is where we finally meet the real heroes of our story, the team within, also known as threads. So let's ask the big question. Multitasking is awesome for handling different apps, but what happens when a single app needs to do a bunch of things at once? Like a text editor that's checking your spelling while you're still typing. How does that even work? The answer is the thread. A thread is the smallest, most basic little chunk of instructions that an OS can possibly manage. And here's the best way to think about it. If a program is a giant project, a thread is just a single item on that project's to-do list. They're the mini tasks that make our favorite software feel so smooth and responsive. So what makes threads so great? Well, first off, they're lightweight. That just means it's way faster and easier for the OS to create and manage them compared to firing up a whole new program. Second, they can run in parallel. On modern computers with multi-core CPUs, different threads can literally run at the exact same time on different cores. And third, they all share resources, like memory, which makes them super efficient. Okay, enough with the theory. Where do you actually bump into threads in your day-to-day life? Let's check out some real-world examples that you already know and use. This table just makes it crystal clear. Think about a text editor. As you're typing, that's one thread, thread 1, handling your keyboard input. But at the same time, there's another thread, thread 2, running in the background checking your spelling. Or in a video game, one thread is busy processing your controller input to move your character, while another one is already loading the next level so you don't have to sit through a boring loading screen. It's this division of labor that makes everything feel so seamless. And this quote just sums it up perfectly. Anytime you see a single application doing multiple things at once, you can bet that it's all possible because of a team of threads working together behind the scenes. So we know what threads are, we know how they work, but let's zoom out to the big picture and really understand why this idea is one of the absolute pillars of all of modern computing.
What is this number? 524. Pretty random, right? Well, in the system that was analyzed for this explainer, this was the number of threads being run by just one core process, the operating system's kernel. The very heart of your computer is juggling over 500 of these tiny tasks just to keep things running. That is the kind of scale we're talking about here. It's incredible.
And it's not just the deep core system stuff. As you can see here, while the system kernel might be juggling hundreds of threads, a standard app might be using over 40. Even a simple text editor is probably using around 10. From the most complex software to the most basic, everything relies on threads. So what's the ultimate payoff? Why do we do all this? Well, it really comes down to 3 huge benefits. First, responsiveness. By putting long tasks on a background thread, the part of the app you're actually clicking on never freezes up. Second, efficiency. Threads let our software take full advantage of those powerful multi-core processors we all have now. And finally, complexity. Simply put, threads are what make the incredibly feature-packed games and apps we use every day even possible in the first place.
So, the next time your computer feels like it's effortlessly performing some kind of magic trick, just remember that silent, coordinated dance of hundreds of tiny tasks happening behind the curtain. It's not magic. It's just the elegant and absolutely essential work of threads. Thanks for watching.